All right, today in Algebra 2, we're going to look at inverse variation and the reciprocal function. So we're starting Chapter 4. Our essential question for Chapter 4, how do you calculate with functions defined as quotients of polynomials, and what are the key features of their graphs? 4.1, essential question, how are inverse variations related to the reciprocal function? And after today, you should be able to use inverse variation and graph translations of the reciprocal function. Today, we're simply going to look at the inverse variation part. So we need to first identify inverse variation. First, let's recall, what is a relation? A relation is a set of ordered pairs. So set of ordered pairs. So example, like 0, 0, -3, 5, 10, 2, any set of ordered pairs. That's a relation. An inverse variation is a relation between two variables such that one variable increases, the other variable decreases proportionally. The product, so remember product means multiplication, of x times y must be a constant. So first we're just going to determine if the table of values given represents an inverse variation. So number one, they give me a relation, x's and y's, and so I want to find xy. I want to find the product of the two. So 1 times 12 gets me 12, 2 times 6, 12, 4 times 3, 12, 4 times 3, 12, 6 times 2, 12, 12 times 1, 12. Did I get the exact same constant every single time? Yes. So yes, this is an inverse variation. Because x times y is constant. So number 2, look at the product of x times y. 1 times 2 is 20. 2 times 17 is 34. Right now, I see that I do not get the exact same constant, so I could stop. I don't even have to continue on. Right? If I wanted to, I could continue. 3 times 14, 42. 11 times 4, 44. 8 times 5, 40. 6 times 5, 30. But not an inverse variation. Because the product xy is not constant. I did not get the same thing each time. Let's look at number 3, list of x's and y's. So again, we're going to do our product, x times y. 1 times 25.5 is 25.5. 2 times 12 3/4 is 25.5. 3 times 8.5 is 25.5. 5 times 5.1, 25.5. 6 times 4 1/4, 25.5. And 15 times 1.7, 25.5. Did I get the exact same thing each time? Yes. So yes, this is an inverse variation. Because my product xy is constant. Number 4, we're going to do the same thing. So find the product of xy. 6.6 times 3, 19.8. 5.5 times 5, 27.5. I can keep going. 4.4 times 7, 30.8. 3.3 times 9, 29.7. 2.2 times 11, 24.2. 1.1 times 13, 14.3. I did not get the same thing each time, so not an inverse variation because xy is not constant. Okay, so this tells us when a relation between x and y is an inverse variation, we say that x varies inversely as y. An inverse variation is modeled by the equation y equals k divided by x, or x times y equals k, or k cannot equal 0. The variable k represents the constant of variation, the number that relates the two variables in an inverse variation. Okay. So let's look at some examples like that. So using inverse variation, again, let's remind ourselves what those equations are. Y equals k divided by x, and x times y equals k. In an inverse variation, x equals 10 when y equals 3. Write an equation, so that's the first thing, to represent the inverse variation. Then find the value of y when x equals -6. In order to write an equation of an inverse variation, we need to know what is our constant k. If I have an x and a y, I can find my k because I have this equation x times y equals k. So 10 times 3 equals k. 10 times 3 is 30, so my k is 30. So my equation, so the first part, the equation, y equals, instead of k, now I know that the k in this problem is 30 divided by x. So those are the first top. Write the equation. Now we're going to use the equation we just wrote, find the value of y when x is -6. So now we're going to plug -6 into our equation. So y equals 30 divided by -6. 30 divided by -6, y equals -5. There's our second answer. Let's do that again. In an inverse variation, x equals 6, y equals 1/2. What is the equation that represents the inverse variation? And then what is the value of y when x is 15? So first we have to write the equation. In order to do that, we need to know what is k. So remember, k is equal to x times y. So k equals 6 times 1/2. So 6 times 1/2, k is equal to 3. So my equation, y equals 3 over x. There's the first answer. Now I'm going to use that equation and plug 15 in. So y equals 3 divided by 15. I can simplify that. Y equals 3 and 15 will reduce to 1/5. There's our second answer. Now we're going to look at using an inverse model. So we're told that on a guitar, the string length S varies inversely with the frequency F of its vibrations. Okay? So I wrote that equation. S varies inversely. So S varies inversely. So S equals, I know K inversely with F. There's my equation. I need to get K by itself, so I can solve for K first. So if I cross multiply, I get K equals S times F. The frequency of a 26-inch E string is 329.63 cycles per second. So they're telling me the string length. So here they tell me S is 26 inches and F is 329.63 cycles per second. It wants to know what is the frequency when the string length is 13 inches. So first, I need to find my equation. So I need to find out what K is. So plug in my S and F. So K equals 26 times 329.63. So K equals 8,570.38. So my equation is going to be S equals, my K we just found, 8,570.38 over F. Use that equation, and I'm going to plug in string length 13 inches. So now at S equals 13. So I get 13 equals 8,570.38 divided by F. I'm trying to find out what F is. I really have a proportion here, like this is 13 over 1. So if I cross multiply, I get 13 times F equals 8,570.38. Divide both sides by 13, and I find that F is equal to 659.26. That's my frequency. This was a word problem, so I need my units. Frequency was in cycles per second. So there's our answer. Let's try another one of those. So number 2, it tells me the amount of time it takes for an ice cube to melt varies inversely to the air temperature in degrees. At 20 degrees Celsius, the ice will melt in 20 minutes. So they tell me the air temp. Oh, I hate it when it does that, and I don't know why it does it. All right, let's go back down. Okay. So they tell me that my air temp, AT, equals 20 degrees. The time is 20 minutes. This was Celsius. I need to write my equation. So I'm going to say X equals time and T equals air temperature. So it says the time varies inversely. So varies inversely, this is like my equals. So my time I called X. So X varies inversely equals some K over my temperature, T. I know my air temperature and my time. I can find my K. So the time was 20 minutes. So 20 equals K over 20 degrees. Again, cross multiply. So I get K equals 20 times 20. K is equal to 400. So my equation, X equals 400 divided by my T. Now I want to solve that. I want to know how long will it take to melt if the air temperature is 30 degrees. So now I know at T equals 30 degrees. So I plug in X equals 400 divided by 30. Simplify that. So I get X is equal to 13.3333 repeating. So I can say that is approximately 13.3. This was time. My time was in minutes. So it will take approximately 13.3 minutes for the ice cube to melt when the air temperature is 30 degrees Celsius. That's where we're going to stop at for today. On Monday, we will look at the reciprocal function and graphing the reciprocal function. Our homework today will be in Envision, section 4.1.